Hi, question number 6 taken from October 2009, A-Level Maths HSC Paper 3. With respect to the origin O, the points A, B and C have position vectors given by OA is equal to I minus K, OB is equal to 3I plus 2J minus 3K, and OC is equal to 4I minus 3J plus 2K. The midpoint of AB is M. The point N lies on AC between A and C and is such that AN is equal to 2NC. Find a vector equation of the line MN, and for the second part it is given that MN intersects BC at the point P. Find the position vector of P. Okay, here is the situation. Now we need to find a vector equation for the line MN. For that we need to find the position vector of M and the position vector of N. Now we are told in the question that M is the midpoint, is midway between A and B. So what I can do, I can find vector OM. So let us suppose that this is vector A and vector B. And here we are, we have OAB. M is here. We can use, it's the midpoint, so this ratio is going to be 1:1. So what we can do then, we can use the ratio theorem to find vector OM. 1 times OB plus 1 times OA. So, and then divided by 2. Because 1 plus 1 is 2. So what we have is, we're going to say OA plus OB, alright, divided by 2. And that's going to give us vector OM. And what is OA? 1, 0, minus 1. So we have 1, 0, minus 1 plus OB, which is 3, 2 minus 3, as given here, and all divided by 2. If you do that, 3 plus 1 is 4, 4 divided by 2 is 2. Then you got 0 plus 2 is 2, divided by 2 is 1. Minus 1 plus minus 3 is minus 4, and minus 4 divided by 2 is minus 2. So now this is the vector OM. We need to find vector ON. So another situation, this is between A and C now. We have the vector N here, and the ratio is 2:1. We're given in the question that AN is equal to 2NC. Alright, so let's find the vector ON. Similarly, we can use the ratio theorem to find the vector ON, which is then 2 times OC, okay, plus 1 times OA, divided by 2 plus 1 is 3. So the vector ON will be 1 over 3. Then you've got inside 2 times vector OC. OC is 4 minus 3, 2. If you multiply that by 2, it's going to get 8 minus 6, 4. Plus, alright, 1 times OA. And OA is 1O minus 1. So 1O minus 1. If you do that, 8 plus 1 is 9, divided by 3 is going to be 3. Then you've got 0 plus minus 6 is minus 6, divided by 3 is going to be minus 2. Minus 1 plus 4 is 3. 3 divided by 3 is 1. So here we have the vector ON. Now that we got vector ON and OM, we can find vector MN. Now we should know by vector geometry that this is MO plus ON, which is then MO. Minus 2 minus 1, 2. Minus 2 minus 1, 2. Plus ON, 3 minus 2, 1. So that's going to become 1. That's going to become minus 3. And that's going to become 3. Therefore, a vector equation for the line MN, a vector equation for line MN can be given as vector M, which is OM, 2 minus 1, this is a point to start, 2, 1 minus 2, so 2, 1 minus 2, plus parameter lambda, and the vector Mn. The vector Mn is 1 minus 3, 3, so 1 minus 3, 3. Now here we are for the first part of the question. Now for the second part of the question, we are told that Mn intersects BC at P. So let us say that this is BC and this is Mn. This vector here intersects BC at P. I can find a vector equation for line BC. Okay, this vector equation, this line I already know. Here we are. Now what is vector BC? Vector BC is going to be vector BO plus OC. So what is BO? Minus 3 minus 2, 3. So minus 3 minus 2, 3. This is vector BO. Plus OC, which is 4 minus 3, 2. And that's going to give us 1, minus 5, and 5. Therefore, a vector equation for the line BC, vector equation for line BC can be given as vector OE, point to start, which is 3, 2, minus 3. So I got then 3, 2, minus 3, alright, plus mu, the parameter, vector BC, 1 minus 5, 5, 1 minus 5, and 5. Now that I have the vector equations for these two, sorry for coughing like this, I got a cold by the way, guys. Okay, bear with me. This equation here and that equation here can be equated. Okay, therefore I can say 2 plus lambda, 2 plus lambda is equal to 3 plus 1 times mu, 3 plus mu. Then 1 plus minus 3 lambda, so 1 minus 3 lambda is equal to 2 plus minus becomes minus 5 mu, 2 minus 5 mu. I can also say minus 2 plus 3 lambda, minus 2 plus 3 lambda is equal to I'm going to need just these two anyway, so that's fine. Minus 3 plus 5 lambda, 5 mu, so minus 3 plus 5 mu. Let's take equation 1 and equation 2. 2 plus lambda is equal to 3 plus mu, so we can say lambda, therefore lambda is going to be, the 2 can come on this side, 3 minus 2 is 1, so 1 plus mu, so this is lambda. Now we can substitute that in equation 2. Equation 2 is this, so we got then 1 minus 3 lambda is equal to 2 minus 5 mu. So 1 minus 3 times lambda, lambda is 1 plus mu, so 1 plus mu is equal to 2 minus 5 mu. Okay, so 1 minus 3 plus minus becomes minus. Okay, plus minus 3 mu is equal to 2 minus 5 mu. Okay, 1 minus 3 is minus 2. Minus 2 goes on the other side, becomes plus. So 2 plus 2 is 4. Minus 3, and you send 5 here. 5 minus 3 is 2. So 2 mu, and therefore mu is going to be 2 mu is equal to 4, and mu is going to be equal to 2. Therefore lambda is going to be 1 plus mu. So 1 plus 2, that is going to be 3. So a vector equation of the line, you can use either lambda or you can use mu. Okay, so not vector equation, position vector of P is going to be then plus, you can either use this or you can use this one. Let's use this, 2, 1 minus 2, and lambda we found it to be, lambda was 3, so we got then 3 times 1 minus 3, 3, 1 minus 3, 3. So that's going to give us 2 plus 3 times 1 is 3, 3 plus 2 is 5. Okay, then 1 plus minus is going to become minus 8. Minus 9 plus 1 is minus 8. Yeah, that's fine. Minus 2 plus 3 times 2 is 9. 9 minus 2 is 7. So here we are for this for the answer. This is the position vector of P. Or you can say vector OP is equal to, if you wish, 5i minus 8j plus 7k. It's up to you. Alright, take care.